Assalamu alaikum. This is chemistry 11th and our today's topic is hydrogen bonding. Now before going through this hydrogen bonding, I would like to give you a recap of various types of bonds that we have already discussed. We have discussed ionic bond, in which we see there is transfer of electrons from one atom to another atom. Then we have discussed this covalent bond, in which we see there is mutual sharing of electrons between the two atoms. Then we have got another type of bond that is called as coordinate bond, which is also formed by sharing of electrons, but in that case we see shared pair of electron that is contributed by one atom only. Then um, and then another type of bond that we are going to discuss today in this lecture, that is hydrogen bond. And this hydrogen bond, it is quite different from these bonds, from covalent bond, from ionic bond, and from this coordinate bond. It represents actually a dipolar attraction, and it is represented by a dotted line between hydrogen it is represented by a dotted line between the hydrogen atom and this and the and the highly electronegative atom, like we have this fluorine, oxygen, nitrogen, in different these polar bonds. Now we see that you can see here this this is when this is an electronegative atom A I have shown here. It may be any electronegative element, especially we have got the highest electronegative elements in the periodic table. We have got fluorine, which has got an electronegativity value of this 4.0, and then comes after fluorine we have got oxygen, which has got electronegativity value, it is 3.5. Then we have got nitrogen with electronegativity value 3.0. So A represents any of these these electronegative elements. Now you can see when hydrogen is attached to any of these electronegative elements, the bond then gets polarized. That means this the shared pair of electrons, it gets displaced slightly towards this electronegative atom, and as a result of which this develops a slight negative charge, while as hydrogen it develops a slight positive charge. Now this electro then now the hydrogen atom of the molecule of one molecule is being attracted towards the electronegative atom of the another molecule by an electrostatic force of attraction, and that electrostatic force of attraction is actually the hydrogen bond. Now we can see the compounds of and these are as I have already told you, the compounds of hydrogen with strongly electronegative elements. I have told you that fluorine, oxygen, and nitrogen. Now frequently show certain properties which can be explained by considering that we see that hydrogen remains the, that hydrogen it exhibits that is the compounds of hydrogen, I will again tell you, with strongly electronegative elements like these fluorine, oxygen, and nitrogen show certain peculiar properties which can be explained by considering that hydrogen exhibits a little affinity for the electronegative element of other mm, for the electronegative element of the other molecule, while it remains firmly attached to the first one. This affinity, this affinity of hydrogen, this affinity or attraction of hydrogen atom of one molecule for the electronegative atom of another molecule causes hydrogen bonding. This means I would say that this hydrogen bond, it serves as a bridge between two electronegative atoms. You can see this is electronegative atom of one molecule. This is electronegative atom of another molecule. So hydrogen, this it acts as a bridge between these two electronegative atoms, holding one by a purely covalent bond and another and the other by purely this electrostatic force of attraction. And this electrostatic force of attraction, I have told you that it gives rise to this hydrogen bond. Now this, as far as its strength is concerned, this hydrogen bond, this is that it is, since it is represented by the dotted line, this hydrogen bond, it is much weaker. It is much weaker than a covalent bond, but it is much stronger than van der Waals. These van der Waals, these interactions. Now, in case of since this hydrogen remains attached to a strongly electronegative element like this fluorine, oxygen, and nitrogen, the shared pair, as I will repeat, the shared pair of electrons will be displaced slightly towards this electronegative, slightly displaced towards this electronegative this atom, as a result of which it develops a slight negative charge, while as this hydrogen it develops a slight positive charge. The, thus this H plus, which has developed a slight positive charge, H plus, it attracts or is attracted by the electronegative element of other molecule. This is the electronegative atom of other molecule. It is attracted by this H plus, or H plus is attracted by this electronegative atom of other molecule. This attraction is, as I have told you, it is a weaker attraction. Now the strength of a covalent bond between this, as I have told you, the strength of this covalent bond is much greater than that of this hydrogen bond. I will tell you here that the strength of this covalent bond between hydrogen and hydrogen itself. That means the hydrogen and hydrogen, in molecular hydrogen we see there is a covalent bond existing between the two, and the strength, that is a covalent bond, and its strength, as I have already told you, that it is 433 kilojoules per mole, whereas that of the H, in case of this I have shown here, this is HF, this is hydrogen fluoride, and had this the bond, that is the hydrogen bond existing between fluorine and fluorine of one molecule, and this hydrogen atom of another hydrogen fluoride molecule. Its strength is 41 kilojoules per mole. This is 41.8 kilojoules per mole. Now, similarly, the bond length or the covalent bond in case of HF, this HF bond length, it has been calculated, it is 100 picometers, and while as the strength of this hydrogen bond that exists between fluorine of one molecule and the hydrogen atom of another molecule, it has been found, it is 155 picometers. So its bond length is also greater as compared to that of this normal covalent bond. Now, as far as conditions of this hydrogen bonding are concerned, we have got one of the conditions is that the hydrogen atom, it must be, one of the conditions is that hydrogen atom, it should be linked to a strongly electronegative element like fluorine, oxygen, and nitrogen, as they have got high value of this electronegativity. Number two is the size of the electronegative atoms. Since these are the three atoms, fluorine, oxygen, and nitrogen, which frequently show this hydrogen bonding, the size of this electronegative atom, it must be small. It must be small, because smaller the size, greater is the polarization. If the size of this electronegative atom is small, then there would be greater polarization of the covalent bond, and greater will be the dipolar attraction. For example, I will tell you here, in case of this nitrogen and chlorine, in case of nitrogen and chlorine, nitrogen has got this electronegativity value of this nitrogen is, it is 3.0. Similarly, the 3.0, while as the electronegativity value of this chlorine, it is also 3.0. Since both have the same value of electronegativity, that is 3.0 for nitrogen and 3.0 for this chlorine. But in case of this, we see that hydrogen bonding occurs in case of nitrogen and hydrogen. Since nitrogen, the size of nitrogen is small, and that of chlorine is large, so hydrogen bonding is shown by NH, this NH bond, and while as this CLH bond, that is the covalent bond existing between chlorine and hydrogen, it does not show hydrogen bonding at all. This is because the size of chlorine atom is greater as compared to the size of the nitrogen atom, because size of this atomic radius of this chlorine atom, it is 99 picometers, while as that of the nitrogen atom, it is 75. Since size of this nitrogen atom is small, and then the size of this chlorine atom, that is why this nitrogen shows this hydrogen bonding, while as chlorine does not show this hydrogen bonding, although they have got the same value of electronegativity. Now, as far as the types of these hydrogen bonding are concerned, we have got two types of hydrogen bonds. We have got this intermolecular hydrogen bonding and we have got intramolecular hydrogen bonding. As far as intermolecular hydrogen bonding is concerned, this type of hydrogen bonding occurs between the hydrogen atom and the electronegative atom of different molecules. Example I have shown here, this is one of the example I have shown. This is hydrogen fluoride. Now here hydrogen bonding occurs between the molecules of between different molecules of hydrogen fluoride. You can see this is fluorine of this hydrogen fluoride. This fluorine of this molecule, HF molecule, it undergoes hydrogen bonding with the hydrogen atom of this hydrogen fluoride molecule. So in this way we see that this hydrogen bonding occurs between the electronegative atom of one molecule and the hydrogen atom of the other molecule. Now another example is that is ammonia. Now again you can see the formula of ammonia. You know that it is NH3, and we see hydrogen bonding occurs between nitrogen atom of one ammonia molecule and the hydrogen atom of another ammonia molecule. Now you can see here, I have shown here this hydrogen atom, there is a dotted line. Again there is a dotted line. You see here dotted line, that means these hydrogen atoms are they are linked to the nitrogen atom of another of other ammonia molecules by means of hydrogen bonds. Now again you can see here, I have shown here this is here free. That means this nitrogen atom, it should be linked to the, it is linked to the hydrogen atom of the other ammonia molecule. Then we have got water molecule. This is water molecule. You can see hydrogen bonding occurs between the oxygen atom of one water molecule and the hydrogen atom of other water molecule, and this leads to molecular association. And obviously you can see when there is association of the molecules, the boiling points also get raised, or they get increased. Then we have got intramolecular hydrogen bonding. Now this type of hydrogen bonding, in this case we see hydrogen bonding occurs between the hydrogen atom and the electronegative atom of the same molecule. Now you can see this is especially it is shown by substituted benzene compounds. You can see here, this is O nitrophenol. This is the nitro group and this is a hydroxyl group. Now we can see the hydrogen bonding occurs between the oxygen of this nitro group and the this hydrogen atom of this hydroxyl group. Similarly we have got this is salicylyl diide, or it's also called as O-hydroxybenzaldehyde. Now here the hydrogen bonding occurs between the oxygen of this aldehyde group and the hydrogen atom of this orthohydroxyl group. Now again we can see here, this is O-nitrovenzaldehyde. Hydrogen bonding, we can see it occurs between the oxygen atom of this nitro group and it occurs between the this hydrogen atom of this aldehyde group. Since we see both the atoms are present in the same molecule, so this type of hydrogen bonding we call as intramolecular hydrogen bonding. This is for tomorrow, for today, and in our next lecture we will discuss the how it affects the physical properties of the elements of this hydrogen bonding. And this is for today. Thank you very much.